This lecture is finding the graph of f prime of x when you're given f of x. That is, finding the graph of the derivative of f of x when you're given the graph of f of x. Let's jump right into an example. I think this is the best way to explain this. Below here, you see the graph of a function. Okay, this blue graph is the graph of a function. Comes down here, has a sharp turn point, and goes up. And if you'll notice, the slope of this graph from here to here is, first of all, it's negative, is it not? It's downhill, okay? And its rise over run is 4 over 4, which means the slope of this graph right here from -4 to 0 is -1. Now what we want to do, that's the function's graph. We want to graph the derivative of the function. And remember, derivative is slope. So we just found that the slope of this line right here is -1. Well, what that means is y prime is -1 everywhere along this graph. So what we'll do is we'll come down to this coordinate system, page that you see here in front of you. And what we're going to do, now this is x versus y prime. And so what we're going to do is we're going to graph y prime equals -1, which is this line right here. Now, if we come back up to the graph, attention to the graph above us here, the original graph of the problem, the slope of this line is 4 over 2, or 2. In other words, y prime is 2. So this is the graph of y prime is 2. Remember, this is y prime, not y. It's going to take a little getting used to this. Now we notice this is a sharp point, so the graph does not the slope does not exist, or the derivative does not exist, to be more specific, at 0. So we have open holes here. It's open, okay? In other words, the derivative goes from -4, 2, but not including 0, and not including 0 out to 2 here. So that's interesting. That's the graph of the slope. Now, let's suppose someone were to give you and say, this is the graph of the slope. What do you know? Oh, the graph of the derivative. You got to remember, the derivative and slope for us are synonymous. Okay? So you look at this and say, well, this is negative, y prime is -1, okay? So that tells me this, I don't know what the graph looks like. In other words, suppose I don't know what you're seeing up here. I do know that the original graph had a slope of -1, and that the slope from 0 to 2 has a slope of 2. I do know that. So if I were given a number of graphs and asked to choose which one was the original graph, I know. Okay. Also keep in mind that everything above, just like up here, everything above the x-axis, y is positive, and everything that's below the x-axis in graphing, y is negative. Well, in this case, everything with the graph of the derivative, everything in this region, remember it's x versus y prime, everything above the x-axis is positive, and everything below the x-axis is negative. It's very important that you understand that. Until you get used to it, it's very cumbersome. When a student sees this for the first time, they really give bizarre answers. But if you think through it, which we're doing together here, it won't be such. One thing I want you to keep in mind, we're giving you the original function and graphing the slope. Later, and this is one of the reasons we're doing this lesson right now, later you may be given situations where you're given the graph of the derivative and asked to give the graph of the original function. In other words, think backwards. So we hopefully, once you grasp this, when we do that, you just kind of flip it and think backwards. Okay, let's go to the next example. Now here we see only one coordinate system, and what we have here are two graphs on this function. We have a red graph and we have a blue graph. The red graph is the original function, and the blue graph is the graph of the derivative. But let's see if we could have figured that out from the red graph. Now, since we've imposed this is the horizontal axis is the x-axis for both. For the red graph, the vertical axis is y. For the blue graph, which is the derivative, the vertical axis is y prime. Keep that in mind. Now let's look at the original graph. The slope from here to here is negative, is it not? Okay. Now, what does that tell us about the graph of the derivative? The graph of the derivative is going to be down below the x-axis. Why? Because the slope is negative, and this is the negative region when you graph in the y prime axis situation. Now, also think the slope, whereas in the previous problem the slope was a constant, the slope here is very steep, very negative, and as we come on down, it's still negative, but it's becoming less and less and less negative. Okay, so till you get here. So that's why the graph has, in other words, the slope is way down here, you know, and we only see it down to -3. This is for size, but it goes way, it's a very big number as you go on down. Okay. Now, on the other hand, let's look at the graph from here to here. Well, here the slope is positive, so you expect the graph of the derivative, which is a blue line, to be above the x-axis, and it is, and it's getting bigger as you go on up. It's getting bigger as you go on up. Okay, so now, does the red graph have a slope at the origin, 0, 0? Yes, it does. So see, we don't have an open circle here because the derivative exists on this graph. See, in the previous graph, we had a sharp point. The graph doesn't exist there, but the derivative does not exist there, but it does here. Is this making sense to you? Let me tell you what this graph happens to be. I'm going to tell you something you can do to practice. This red graph is the graph of y equals x squared. Okay? What's the derivative of x squared? And 2x. Okay? And what's the slope of the line y equals 2x? 2. Well, what's the slope of this blue line? Well, it's 4 over 2. Is it not? Or 2. What I'm getting at, you can make up what you should do if you want to really understand this. Most of you have a calculator that graphs. This day and time, calculus students have been using graphing calculators. Let me suggest something to you. Make up a function. Say y equals 3x squared plus 2x and graph it in your calculator. And then what's the derivative of 3x squared plus 2x? It's 6x plus 2. So graph that and see if it doesn't match up with what we've said here. In other words, and then after you do that, try something like y equals x cubed, whose derivative is 3x squared. So graph y equals x cubed and graph 3x squared and see if that graph of the derivative doesn't say what we said. In other words, you could have predicted what it was going to look like. When you get, so you don't need your instructors to be giving you additional problems or textbooks giving you problems. You can make up problems of your own. Okay. Now we go to the third and final page of this lesson. What I have here are three graphs of functions. And here we have the graph of three derivatives, the derivative of functions. In other words, this is x versus y, and this is x versus y prime, okay? Now, your job is to match up the graphs here with the graph of the derivative. So let's look at, say, A. What's the slope of the line as you go from here to here? Well, it's uphill the whole way, is it not? It's uphill the whole way. In other words, except here at the origin where it's momentarily zero. So it's uphill the whole way. Now, remember that the graph of the derivative, in other words, the slope is always positive except at the origin where it's zero. Now look at this. Is the slope always positive here? Well, you say, yeah, this is uphill. No, 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 no. This is the graph of the derivative. Here it's negative. It's below the x-axis. Here it's positive. We want one that's above the x-axis the whole way. So wouldn't that be R? R is above the x-axis the whole way. Now let's look at B. B has a slope that's positive or negative, excuse me, from here down to here, the turnaround point. Well, we want to find a graph that's below the axis from here to about here. And wouldn't that be this? And then it has a positive slope from here to here, and we want it above the x-axis from here to here. Wouldn't that be here? And then it has a negative slope from here to here. Wouldn't that be below the x-axis from here to here? And it is. And then the slope is positive the rest of the way here. And so wouldn't that be above the x-axis? And it is. Okay, so slope is negative below the x-axis. Slope is positive, okay, above the x-axis. Slope is negative below the x-axis. Slope is positive from here to here above the x-axis. I may have twisted some of that saying it twice, but in other words, make sure you understand that. Slope is negative below the x-axis. Slope is positive above the x-axis. Slope is negative below the x-axis. Slope is positive above the x-axis. Now let's look at this one. Okay. The slope is always negative till you get here, and then always positive. In other words, always below the x-axis, always above, and that's P. Okay. So make sure you are following this. This is a very brief lesson, but in the scheme of things, especially in the days when nowadays textbooks have the ability to make graphics and they can ask many more interesting questions. And see, there's there's no calculator. People say the calculator can do the work. There's no calculator that can work this problem for you. Okay, calculators really of very little use unless you are given the equation, and we're not given the equation here. So that will be the conclusion of this lesson.